Hello everyone. Today's topic is LVM. LVM we call Logical Volume Manager. To understand the LVM, we must know about the three components of the LVM. They are interconnected and together form a logical volume. What are these three main components are? First is physical volume. Second is volume group. Third is logical volume. What is the main that physical volume, volume group, and logical volume? Let's understand physical volume. Physical volume we called our actual hard disks, means that is physical hard disks. Volume group. Volume group is a pool of storage created by combine one or more physical volume. To create a LVM, we required some physical hard disks, and for that physical hard disk, we create a storage pool created by that combined hard disk. So we call that volume group, and we create a virtual partition from that volume group. So you can understand how they are interconnected and together used to create a LVM. So these are the three main components. In interview, suppose interviewer asks you what are the three main component of the LVM. So you give the simple answer: physical volume, volume group, and logical volume. These are the three main components. Again, he asks you how they are three components or why they are used. To give the simple answer, because they are interconnected and together form to create a logical volume. Suppose if you not use any one of the options, that is physical volume or volume group, without them you cannot create a LVM or logical volume. So we required first option, always we required a physical hard disk to create a logical volume and volume group. So here is some basic steps how to create an LVM. To set up a new logical volume, we follow these steps. Step 1. What step 1? Create physical volume from available hard disks. Means we require a raw hard disk to create a physical volume. Second, create a volume group and add a physical volume to it. Means to create a volume group, and whatever we create a physical volume, that hard disk add into the volume group. Third, create a logical volume from the volume group. Means you can see volume group is a pool of storage, and they are combining one or two hard disks. Means once you combine one or two hard disks, you will get total disk size into the volume group. Why? Because it is a pool of storage. So from that volume group, you can create a logical volume. Fifth, format the logical volume with ext4 or xfs file system. Our fourth step is to format that logical value. Then fifth, mount the file system to a directory. After format the logical value, we have to mount that directory into the file system with the help of mount command. This is an overview of the LVM. If you see my previous video, how LVM works behind the Linux system, so you will get idea to create a LVM into the Linux system. Those people who are into newcomers in my channel, so please watch my previous video to learn how LVM works, what are the components required to create a LVM, and in this video we learn the practical of the LVM. So today we learn about LVM. We do the practice how LVM work into the Linux system. So first I am going to shut down this my machine. After shut down the machine, I am adding the three new hard disks for LVM. I am go to edit virtual machine settings, then going to add option, select the hard disks, click next, click next, create a new virtual disk. You select this option, click next. Here I am use 20 GB hard disk. Click next and finish. Again I am adding second hard disk. Disk type is SCSI. Click next. Create a new virtual disk. Click next. My hard disk size is 20 GB. Click next. Finish. Again add a new hard disk. Click hard disk. Next. Disk type SCSI. Select disk. Create a new virtual disk. My disk size is 20 GB. Click next. Finish. See. Then OK. Now you can see we successfully add our three hard disks into our virtual machines. Now I am power on this machine. Now you can see my machine is booted. If you want to learn about LVM, you can also see my previous video, that is LVM details. It very helpful to get understand how the LVM is work and what is the use of LVM. So don't forget to watch my previous video. After successfully boot the Linux machine, I am coming to my putty session, then restart my session and log in the Linux server. Now, after that I check my three hard disks is successfully added or not into the Linux server with the help of fdisk command. fdisk-l c fdisk-l command which is show us that our three hard disks is successfully added into our Linux server. There is one more option you can check /dev/sd star. See, when you use /dev/sd star command, you can also see our hard disks, new hard disks which is present here. To see hard disk is properly added or not, you can use fdisk-l command. It shows we successfully have added our new hard disk. That is name is SDB, SDD and SDC. So now we have to format this hard disk with the help of fdisk utility. fdisk/dev/sdb. See, once you hit the enter, it give you the command line interface. So for command, if you type M, you can give lots of options here. So we have to create a new partition. So we use p command. You can see there is SDB hard disk detail is present. So to create a new partition, we type n. N means new partition. P for primary. Partition number we give the default. First sector we give default, last sector give default. Okay, then after that we type T and we use 8. First we use the L command to list of which type of partition of hard disk we require. So we here required LVM type. So where is our LVM? What is the code of that? We checked here. See 8E. 8E our is LVM code. So we type here, then save the changes. First we check P for print. See, when we type a P command, we check that we have successfully formatted our SDB hard disk. The ID of SDB hard disk is 80, means that type is Linux LVM. Now use W command to sync that hard disk detail. So we have successfully format our one hard disk. Now we format second hard disk, fdisk slash dev sdc. This is our second hard disk. N for new partition, P for primary, partition number we select by default, first sector we select by default, and last sector we select by default. Then we set that disk type is LVM, that is 8E. Enter P for print. C SDC we successfully formatted. Then press W to sync that detail into the partition table. Then one more hard disk we have to format. Same step we follow, fdisk slash dev slash sdc. Enter, create a new hard disk. Sorry, SDC we already did. Control C. We have to use SDD. Enter. N for new partition. P for primary. Partition number default. First sector we set default. Last sector we set default. Then select a type. Which type we want? We want Linux LVM type, that is 8E. Enter. P. P for print option. With the help of this option we can see our SSD hard disk is properly formatted. The ID is 8E and type is Linux LVM, and then we use a W command to sync that hard disk detail into the partition table. Now after successfully format our 3 disk, after successfully format our 3 disk, then that disk we add into the LVM. So here I open one duplicate tab. See, now we successfully format our three hard disks. So our first main component is physical value. So our physical volume, how we convert it into the physical volume group, means our physical hard disks, how we convert it into the physical volume. So to convert physical hard disks into the physical volume, first we required one or three raw hard disks. So once we get that raw hard disks, that hard disks we add successfully into our Linux machine. After adding that hard disks, we need to format those three hard disks one by one with the partition type is Linux LVM. So after successfully format those hard disks one by one, we add those hard disks into the physical value. So here first we check any PV is created or not. See, PV is not here. So we use pvcreate command. First we check. hmm, First we check our LVM is already installed or not. So here you can see your dev mapper cs home xfs. This is your LVM partition. So first we create physical value with the help of pvcreate command. Pvcreate slash dev slash sdb slash dev sdc slash dev sdd. See, we have to use sdb1 slash dev sdb sdc1 then slash dev sdd1. See, with the help of pvcreate command, we successfully add sdb1, sdc1 and sdd1 hard disks into the physical value. With previous command, we can see sdb, sdc and sdd disk successfully added into the physical value. So we successfully complete our first component physical volume task. After that, we have to create a volume group. So, what is volume group? Our simple answer is a pool of storage created by combining one or more PVs, means one or more physical values. So, to create a volume group, we use vgcreate command, then vgname, then your physical value sdb slash dev sdc slash dev sdd1. To create a volume group, we required first vgcreate command, then our volume group name and our physical volume name, means we create a physical volume with the help of pvcreate command. For that we use sdb1, sdc1 and sdd1. So same physical volume we have to use to create a volume group. So here we use vgcreate command, our vg name and our physical volume name, that is dev sdb1, sdc1 and sdd1. See, we successfully create our volume group. So how to check that volume group? With the help of vgs command. See, vgs command we shows us we have successfully create a volume group that is named vg data, and what is the size of our total hard disk? We use 20 hard disks. So that total size is 16 GB. So here we use VG size is 60 GB. Means that physical volumes combine together to create a volume group. Also you can use pvs command to check how many hard disks you added into the volume group. So in pvs command you can see sdb1, sdc1 and sdd1 belongs to your volume group, that is the name of vg-data. So there is one more command, pvdisplay. Pvdisplay shows you physical volume, then vg name, your disk size, currently is usable or not usable, it shows, then it is allocatable, yes, and then your pvuid, it shows us this kind of details. Then one more command, vg display. See, vg display shows your vg name, vg hyphen data, metadata area, that is 3 hard disks. You can see vg axis read and write, that is resizable, total size is 60 GB and vguid you can see. Now after create a volume group, we have to create logical value. How we create that logical value? Virtual partition created from the volume group means we have successfully create our volume group, means that volume groups come from our physical value. So our volume group size is 60 GB. So we have to use that 60 GB size for our logical value. So how we do this? See, we can use lvcreate command to use that 60 GB hard disk size. We use lvcreate command. Lvcreate command, then our lv name, lv hyphen data. After that we use hyphen l space 100% free and our vg data name. To create logical value, we have to use lvcreate command hyphen hyphen our lv name, then use small l hyphen l 100% free. To whom we want 100% free? We want 100% free size from vg data. C lvs. So after adding 100% free space from vg data, we have to see our vg comes here the size from 16 GB. So today we learn how to use 100% size get from vg data, or we collect 100% disk size from vg data. There are two ways to get a desired size from vg data. One is 100%. We use hyphen small l command and hyphen capital L command. We can use desired disk size space from vg data. So what is the purpose to create a lv logical value? To create a logical value, the main purpose of get some amount or get 100% free disk space from vg data means logical value. So once you configure logical volume perfectly and you add your physical hard disk into the logical volume, so you will successfully get desired space from your logical value to create a logical volume. So here we successfully add 100% free space from vg data. After successfully added logical value. We have to format this logical volume to our desired file system, that is ext4 or xfs. We have to perform above three steps. We perform above three steps to create a logical volume. First, we create a physical volume, then create a volume group, and then create a logical volume. Now, we format that logical volume with the help of mkfs dot xfs command. Then our path is dev slash vg hyphen data, then lv hyphen data. Now you have to confuse how I give this part to format that LVM partition. So very simple. This is very simple things. We have to format that LVM partition. So what we required? We require dev. Dev means our physical hard disk. So that physical hard disk we converted into VG data and LV data. So you can see we have to create VG data and LV data. So our path is slash dev VG data and LV data. So now after successfully format that logical value, we have to create one file system slash LVM. See, I am creating LVM file system and mount that file system slash dev vg hyphen data lv hyphen data to my LVM file system. See, we have successfully added that LVM file system into the Linux server. You can see that my slash dev mapper vg hyphen data lv hyphen data, that is a path. We use xfs file system. After successfully mount our logical volume into the LVM directory, you can see df-th command that our volume group is properly mounted or not. If you are doing all necessary steps perfectly, so your LVM mount point is mounted successfully and it is mounted to the LVM directory. So you can see whatever step we follow with the LVM concept, we have successfully added our three primary hard disks into the LVM. To next video, we learn, suppose our LVM directory is getting full, and in that directory we have important logs or other files. So we cannot move that directory and files to another file system. For that, we extend that LVM file system with the help of LVM. So today we learn how LVM works with physical hard disks. To learn LVM, we required three physical hard disks. That physical hard disks we have to convert it into volume group, and that volume group combine together and create one logical volume. For that, after create a logical volume, we take 100% free space from the volume group, and then we format that logical volume with the help of mkfs file system. After that, we create a one directory into the Linux system, and that logical volume mounted to the LVM directory. And you can see that we take a 60 GB combined hard disk, and that 60 GB hard disk size we can see into our Linux system. I hope you enjoy our session. Thank you very much. Have a nice day.